Yes, Sanjeev, tell me.
Pratik, I hope the 3 questions you have sent yesterday, that is not included as assignment, because that was supposed to send it back to you, or it was just practice at our end, because I practiced at my end. Yes.
Practice question. Any? Did we create? I mean, that's
The
fine.
3 questions you said na, to try 3 questions. You said na yesterday.
That's fine. That's
That's
fine.
not included as the assignment part, right? The rest,
No.
rest I have sent it. Yeah.
No, that's fine. That's fine.
All right. Thank you.
Let's look at this. Yes. So what we are doing is we are doing a quick recap of inner join, right? Then we will also talk about different flavors of joins, right? And why do we and when do we need different flavors of joins? But look at this. Imagine you have a table called as employee, which is like a master employee table, all the employees in a company, right? And then you have another table called as department. That department table has a list of departments in the company, right? In the employee table, if you notice, there is a column called as department ID, which is common with the department table. That means, what is the foreign key in this relationship, guys?
Department ID.
In the employee table, right, Faisal?
Yes.
The department ID in the employee table. Now, if I were to ask you, please give me list of all the employees who are assigned to a department. Also show the department name. So that means if you look at this request that I have from a business manager, that I want to see all the employees, and at the same time I also want to see the department that they're assigned to work with, right? If there is an employee who has not been assigned to any department, then I don't want to see those employees in my report. Did you all understand this? So if you notice here,
Yes.
Out of these 6 employees that we have, there are 2 employees, Pratik and Ravi, who are not assigned to any of the departments. Is it making sense, everybody? And also, if you notice, there is a department called as operations, which doesn't have any employee to it. You can see this. The department ID is blank for operations department. Is it making sense?
Yes, Pratik.
So the output that I'm looking for would have employee name and would have department name, right? The employee name will be Ivy, Rakesh, Saurabh, Gaurav, right? And the department name for Ivy will be IT, Rakesh will be marketing, Saurabh will be HR, and Gaurav will also be.
Pratik, for Rakesh, it will be IT.
Yeah, right. Do you all understand this? Everybody is clear?
Yes.
Yes.
Here, what we have done is, if you look from a Venn diagram perspective, suppose this is employee table and this is department table. So this here represents what part in this Venn diagram?
The intersection
Department name.
This shows
Department ID.
intersection part. I get a point. The common rows between the two tables. And how did we find the common rows? We found the common rows on the basis of
union.
Nahi yaar.
Department ID.
Join.
we found the common rows
Intersection.
table is through these two common columns.
Foreign key, yes.
Foreign key use.
I mean, the common columns essentially, right? Because if you notice, I mean, we said that, okay, for this employee, I want to know the department. So you said, all right, this department, where is that here in this table? And you said it's here. And what is the department name? IT. So what did you do? You equated employee.department ID equals to department.department ID, right? And wherever that combination was, that where common columns values were same, and those are the values that you picked up. Is this clear, everybody?
Can you repeat that dot part where you are joining?
No. I will come to it, Faisal. Have you understood that, on the basis of the common column, we found wherever the common columns value was same,
Yes.
we said that, yes, that is the department that particular employee is assigned to. That you understood, right?
Yes.
Faisal? Yeah?
Yeah. Yes.
Now look at this. And you also understood that this is the common common column that we're talking about, right? Common section, intersection between the two Venn diagram that we're talking about. Right, Faisal? Now, since in this query here, in this output of the
Yes.
query, in this output of the query, we need column information from the employee table, because this emp name will come from the employee table. And this department name will come from which table?
The next table, the other one.
Department table.
Yeah. And the common column would be the department ID, which is.
That's fine. But I'm just saying, in the output that we're looking for, in the report that we're looking for, we need column information from two different tables, right, Faisal?
Yes.
Whenever you need column information from more than one table to be shown in one report, Faisal, that's when you think of joining the two tables.
Yes.
That's when you think of joining the two tables.
Joining the two table horizontally.
So here we will write from, and how do we join? So we join it like this. So from employee, comma, department, right? The moment you write from table 1, comma, table 2, the two tables are joined, right? Then if we write where employee dot employee dot dpid is equal to department dot dpid, department ID, right? That means this statement will convert this join into what kind of a join?
Inner join.
Intersection join or inner join,
Inner join.
right? So we will write, select, say, imp name, comma, d name. You understand, Faisal?
Yes, Prateek.
Tell me, I think you still have some doubt in your mind. What is that?
Prateek,
Hmm.
if we have to use where or in join, so which one should we prefer? I mean, we can use like this as well.
Here, what do you think we would have used otherwise, Shweta?
Simply where department ID equal to because I was going through the questions where if you say gender is married, so where clause is.
See here, if you notice, we need information, we need column information from two different tables, employee name from employee table and department name from department table in one output. I get what?
Okay, yeah.
So in this case, there is no other way.
Okay, understood. Yeah, I understood. But instead of where or in, we should.
Instead of not where, instead of where or inner join, the other way of writing this query is inner join, right?
Yes.
Suspected match and record suspected as match and there is one more. Does not exist. Two lives. Okay.
Yes. Yes.
Right.
Yeah. That is why.
Both are same. I prefer to I would recommend you to use this method. One is simpler, and typically a lot of times the databases optimize this method, and this method runs a little faster than this method.
Okay. Understood. Thank you.
Pratik, can you explain the syntax for inner join again?
Yeah. So, sorry. From
Yeah.
employee, that means from table 1, inner join table 2, on what logic? That means on which column are you inner joining them? So on the basis of this common column, Sanjeev.
Yes, yes. Now I got it.
Okay. See, there is another method. Okay. I mean, there are so many methods. There is another method actually. Using this method can be used when the common column has exactly the same name, Sanjeev.
Okay.
Because at times it may so happen. In fact, you can see here it's called as DEP ID and here it's called as DEP ID. In this case, we could not have used this method. Here the common column should have the same spelling. But this method is more universally accepted.
All right.
So basically we are populating the employee name and department name, and the logic is given there in the next line saying that the inner join should be this field equals to this field.
Inner join should be on the basis of this logic.
Okay. And what is this E dot? Are we concatenating?
No, no. What we are doing is we have created alias names for the table so that it reduces my typing effort of writing the entire table name before the common column. Table name dot common column.
Oh, ASD.
So Pratik, this alias is same as we use
For the
variables.
columns. Absolutely right.
Yeah,
Same.
okay.
So there also the as is optional. I mean, if you just write a space, which means that, okay, we are creating a short form, an alias name for this table E, and for alias name for this table D. I get my point, Faisal.
Yes, I'm trying to wrap my head around this code.
Maybe simple, Faisal. I mean, let's say you don't understand. Let's say you don't understand what is going on in here, right? So
yes, I can, but find the last one much simpler one. Select
this one, right? This one.
This one.
Yeah, because this is more manual. So from table 1 comma table 2, where the table 1 dot common column is equals to table 2 dot common column.
Yes. So basically we are creating a unique field by using that dot thing and simply doing a VLOOKUP in terms of
yeah. Actually,
SQL.
it is like exact match VLOOKUP.
Okay.
This is exactly same concept as exact match VLOOKUP.
Okay. I find the last one was simpler.
Pratik, I want to ask in the both table department ID and department ID, the name is different. So there is T and the other one is not exists the T. So
you need to correct it. Yeah.
So we could have avoided writing the table name as well. In this case, if the spellings are different. because then there is no ambiguity. But most of the time, we will end up creating the foreign keys with the same spelling. So, do you understand what I'm trying to say?
Means it's a typo error or
Yeah, it's a typo error.
okay.
But you know, again, the foreign keys
Okay.
can have different spellings also, Vivek.
Okay.
Here it could have been called as DID. Doesn't matter.
Doesn't matter. Okay.
Yeah, anyhow, we're using the equation here.
Yeah.
Okay.
Correct.
So Pratik, we have three ways of joining table. The first one was Cartesian method, where we just simply put the table name from, both the table name and the keyword from, and the condition we met on the same column, right? Where the column table one dot column equals to table
No.
two dot column.
Wait. This, when you stop
Yes.
the query, suppose if you stop the query here. Sorry. Suppose if you stop the query here, Gunjan, right? Then it is Cartesian join.
Okay.
That means all the columns of table, first table will be added with all the columns of second table, and each row of the first table will be combined with each row of the second table.
And then we put the where clause.
But when you put the where clause, then you're changing the nature of join.
And that become an inner join.
Yes.
Okay. This was the first method. The second method you told about using the keyword join on.
Inner join with on.
Right. And the third was using the keyword using.
Yeah. So third one is
होगा suspected.
I get a point, Gunjan.
Yes. So basically, while using the earlier two methods, we have may have different column name.
Yeah.
But while using the keyword join, we have to keep the column name same in both the
Then
tables.
while using, then you have to have the common columns name same.
Right.
It is SID, Pratik.
Sorry.
The common column is SID, S.ID.
S is alias.
S is alias. Yeah. I mean.
Okay.
Is this clear?
So all the three methods are the same, and there's no unique usage of any of the.
Hey, see, I tell you from a speed perspective, Faisal, this method and this method would be faster than this method.
Okay.
And the reason is, you see, what happens is, it's like, you know, these are system optimized. That means the moment a database software sees that, okay, you're using inner join, that means they know that, all right, you know, it's going to be a big operation. Let's optimize it. Let's open both the tables together. Let's do a few things which, you know, even I don't know. But, you know, I mean, that's where the databases differ from each other. So SQL Server may say, Microsoft may say, hey, in our database SQL Server, we optimize the join queries very nicely so that the queries run very, very fast. See, you know, what happens is, imagine when you're Googling something, right? When Google became popular, it became popular, of course, because of accuracy of the result. And the second very important factor why it became famous was, Faisal, the Google searches.
It was accurate and it was quick.
It was the quick speed, right?
Yeah, the search
And
engine
speed,
was very quick.
Yeah. And that speed is where the different database softwares differ from each other. Because some databases will say that, okay, we are highly optimized. You know, we optimize our, you know, pattern matchers very nicely. We optimize our joins very nicely. You know, we fetch them, we index them. We, you know, I mean, they apply a lot of system, system design. methods internally, algorithms, and so on and so forth to optimize these search queries. Right? So, I mean, here we don't realize because the tables are small, right? If you are working on tables which have a few terabytes of data, and if these queries are going to run on few terabytes of data, then you will realize the importance of speed. Okay, see, I tell you, just to give you an example. If you remember Google BigQuery, I don't know if you guys got an opportunity to see this interface. I'd given you guys the video to kind of use this interface as well. It's again. Shweta, did you do it?
No, workbench. I don't want to get confused. So at so many platforms.
Anyway, just to show you guys, say for example, this baby name. This is one of the sorry, yeah, baby name. All these are publicly available databases on Google Cloud Platform, and they may have terabytes of data in them. And I'll show you that how simple queries. Say for example, here, if you notice, we want to understand in which country. Okay, country names, these are not baby names. USA names. Yeah, so if you notice here, there is a field here called as state, and there is a field here called as name, and there is a field here called as number, which essentially shows you how many times Mary in this state, in this year, how many babies were named with Mary in this year, in this state. Do you understand what I'm trying to say, guys? Right? So look at how many rows are there in this table. What, 6.2
million.
6.2 million, so 62 lakhs. Am I reading it right? No, 6 lakhs 21,000. No, 62 lakhs.
62 lakhs.
62 lakhs rows are there in this table, right? 6.2 millions, which is quite a bit, right? So if I were to write a query on this this database, so say for example, give me a second. Suppose I write this query, and we will talk about this query shortly at some point of time, maybe this week only. So if you notice, this is the database project name, this is the database name, and this is the table name. And imagine if I say group by, which is essentially a construct that we will learn very shortly. Group by state, comma name. If you notice here on the top, Do you see this here? It says this query will process 70 MB of data, megabytes of data. Okay, million bytes, meaning megabytes of data when run. Now, what happens is in these cloud platforms, okay, when you are running a query on a large database, right, depending upon how much of data it will process, you will be charged for that query. So Google is going to charge the user. I mean, this is a free sandbox free environment, but Google will actually charge the user that much money. I mean, money is defined on the basis of how much megabytes are used. But the more you use, the more money you would be charged. Is it making sense? What I'm trying to say, guys? Right?
Yes, Pratik.
So if I run this statement, see here, it is processing. Is going to tell you how much. Yeah. See, it took like 6 seconds to process it, and this took only 6 seconds because the data is hosted on a very fast Google Cloud server. I can tell you with full certainty that if we had data in our local machine, right, of such large data, it would have taken us an hour to run. So then the speed becomes very, very important thing, right? I mean, in fact, 5.3 seconds is also a very large time period that it took to run this query. I mean, so that's how the companies try and optimize their queries further and further. So if you notice, this is the data that we gotten, that Mary 100 time in Arkansas, Annie how many times, Anna how many times, and so on and so forth. Do you understand? And that's the main benefit of using SQL, that you can actually run queries on very large data, provided provided you have access to such fast servers and fast processors. Okay. So yeah, I mean, that's when it becomes important that you're also careful about the speed, and that's why among all these three methods, I would say that try to stick to inner join method, which is most commonly used across, or this method instead of this particular method. Okay. Now, I'd given you guys 3 questions yesterday. What were the 3 questions? Does anybody remember?
Yes.
What are the 3 questions?
Loans new database and customer name and city they live in.
These are the
list.
questions.
Yeah.
Right? Customer names and the city they live in. So, of course, we want to use the loans new database here. Saikat, you created your own table also.
That was mistake.
I will still go ahead and drop it.
You have to use CC profile ones, I think.
Are you sure?
Yeah, that is what because we need customer region as well, right?
Maybe you're right. Yeah.
Right now only I'm.
Yeah. Sorry. Yeah, you're right.
Yeah.
Yeah, you're right. So we will use. Yeah, so customer name, and the city they live in. Now see, the name will come from this table, whereas the city will come from customer's region table. That means we need column information from 2 different tables, and hence what we will do is we will need to join the 2 tables, right? So the 2 tables that we will join here would be from customers, let's say C, inner join.
Just for my understanding, so we'll not use loans underscore new database, right? We'll use CC underscore profile underscore DB, that one, right? Okay, because I was not finding the name and the city. Okay.
Yeah,
I got it.
Yeah,
okay.
Sorry. Should I mention that? From customer C, inner join. Which table? I'll just rename it also.
From customers.
Customers C, inner join, customers underscore.
Customer region.
Region.
Yeah.
CR on C dot
Cust
cust
ID.
ID is equals to CR dot cust ID. C dot cust ID, comma,
Name.
name is a column, yeah, name, and then city. It runs, gives you the output like this. Does it make sense, everybody? For the second question, find the list of married customers from Midwest and South regions. Married customers from Midwest and South region. So married information will come from the customer scale, marital status is there. Midwest region information is going to come from the region table, right? So we'll have to join these two tables then. Customers and region underscore data.
Yes, Pratik. Pratik, can you tell this also from where you get this information section here? In the left bottom column, yes, this.
So this one, when you
Yeah.
select a particular
Yes.
column, sorry,
Yeah, yeah.
when you select a particular table, it automatically gives you that.
It wasn't coming at my PC, but
And
we'll try.
Don't click on this.
Okay.
Click on the actual name.
All
If
right.
you click on it, then it'll actually show you this. Here also you can see that columns, but then it just makes your more levels. So I like
Okay.
to see the
I think-
columns.
I think by default it mostly on administration. So schemas pe click karna padega. You have to, and then
Yeah, you'll have to go to schemas and then click on it.
Okay, okay.
it will also show if we write a code to select a table. Will that show?
If you write what, Faisal?
If I write a code to select that table.
Yeah.
Will it show?
No. If you describe the table, it will show.
Oh, okay. Over here, okay.
But that's too much, right? I mean, why do we want to use these graphical user interface a little bit is to help us in such things, right?
Yes, Pratik.
So the second question is find a list of married customers from Midwest. So married customers, so we'll require customer C inner join region data and on the basis of, now you can't really join customers table and the region table. Do you understand why?
because they don't have common column.
Because there are no common columns. There is a common column between customer and customer region. So we'll have to stick with that. So married customers. So that means where marital status is equals to married, right? And region
Midwest and South or South.
So a lot of things are happening in this query, guys. First, the two tables will join on the basis of this logic. Then it will actually filter all the students, all the customers who meet these two criteria, and then it will select these columns for such customers from these two tables. So a lot of things are happening, guys, behind the scene. A lot of things, and that is the real power of SQL. That is the reason why, one of the primary reasons why we use SQL more than anything else, because you can keep joining multiple tables from different databases as well, as long as they have some common columns.
Pratik, please explain this last part of this query. Where in you're applying?
This one,
Yeah,
Yeah.
after the end.
this and region could be either Midwest or South, right? So I could have written it like this. Region is equals to,
In bracket, we can use the OR function.
yeah, in bracket, I could have used the OR function. Like, maths BODMAS rule, if you remember, or region is equal to South. I could have used something like this, but then, it's just too much of typing effort. I get a point, Shweta.
Yes.
Yes.
Yeah. We know that in can replace multiple OR statement. So hence that's what we have done here. Region in this list.
Yes, Pratik, fair enough.
All right. Good then. Let's continue our discussion to one more type, a couple of more types of joins, guys. Here, coming back to our these two tables, employee table and department table. This question was that we find the list of those employees who have been assigned to the department and ignore the employees who are not assigned to any of the department, right? So we just wanted to know the list of employees and the list of department that they are assigned, right? But what if my question is a little different? My question is list all the employees along with their department full name. List all the employees. The keyword here is to understand all. This is important to understand. List all the employees. And here it was list only those employees who are assigned to a department and their department name. The question was different from here. So the main difference is here we are saying list all the employees. Is it making sense, everybody?
We are not.
That means we are also interested in seeing these employees as well, Fazal.
Okay, all the employees along with the department full name.
Hai now, all the employees. These two employees are not assigned to the department. Hence, in the output for these two employees, the department column, the department name column should remain blank. Should have null values, right, Fazal?
Yes. So a blank column should also be a part of department, as what we can see.
Look at this. Look at this. This is the output that we are looking for.
Yes, but my question was there is this employee table and this department table. So in order to get a null value for Pratik and Ravi, should there be a null column for department in department
This
table?
is department name, right, Fazal?
Yes.
And it doesn't show any value here. That means null value.
So if I don't have these two columns, these one, will it show the same result? Or
meaning, what are you saying? I mean, I'm saying, did you understand what I said here? I want
yes,
I want the list of all the employees along with the department full name.
Department full name, and where there is blank, it should show the department name as blank.
Yeah,
right?
That's it.
Okay.
Got it?
Yes.
See, here we wanted to know in the first query where we did inner join, we wanted to know only those employees who are assigned to the department and their department name. That means the employees who are not assigned to any department, they were ignored.
Not
right?
sure. Yes.
But here we are saying that no, I want complete list of employees. I want the complete list of employees. Now, if there are certain employees who have not been assigned to department, right? I still want them to be shown in the list. The department column will remain blank, right? So if I were to say, this means I want the complete list of employees, right?
Yes.
Right? Including
The one
those employees who have been assigned to the department and their department name. Right, Faisal?
Yes, yes.
Plus
The one that are not. Yeah.
that are not. So it's like saying employee minus department, which is this portion.
Yes.
Right?
And the common one as well.
Plus added with the rows from employee intersection department. Are you all with me on this, guys? Basic set theory we are talking about.
Yes, Pratik.
But this may not be necessarily equals to E. What is E?
That is a different table, right?
What is E?
Department name and the number.
Employment table.
E is the employee table. Right? Now, why am I saying it may not be equals to E? Because if I were to say that I want the list of all the employees, I would have gotten the list of all the employees, then then why did we have to go through this much of pain? The difference here is what? What is the difference that we are getting here by doing this? That we want the list of those employees who have not been assigned to the department plus the list of those employees who have been assigned to the department and the department name. What is the extra bit of information are we able to get with this operation?
So Pratik, basically,
Department name.
what we are getting in employee table is the department name. This is the simple query
Right.
that we are running.
For those employees who've been assigned to the department, we can now get the department name for such employees.
Yes.
I get a point. That is an extra bit of information that we are getting from the other table. Clear, guys? So if I were to show it in a clear, clean window, then what are we saying? We are saying this is our employee table, right? And let's say this is our department table, right? Now we know that there are certain employees who have not been assigned to any department, but most of the employees are assigned to some of the other department, right? So if I say that I want the complete list of employees, that means this is E. But the moment I say that for these common rows with the department, that means for the employees who have been assigned to the department, I want to know the department name. This is no longer E. This means I also want some information from this other table. Do you understand what I'm trying to say, guys? So
Yes.
here I want employee name, which is going to come from the employee table. And I also want the department name, which is going to come from the department table. Hence, we'll have to join these two tables. But it may so happen that it has so many rows, and here there are only so many rows. There are some employees who have not been assigned to department, and hence this will remain blank. Does it make sense?
Yes.
This kind of an operation where we say we want all the rows of the left table, including the matching rows from the right table. What did I say? All the rows of the left table, including the matching rows from the right table. This kind of an operation is called as what?
Left join.
Left join.
Left joint.
Left outer join or left join. Okay. Why are we calling it as a left join and not a right join? The reason why we are calling it as a left join is because I have assumed the employee to be on the left hand side in my Venn diagram. That is the only reason why we're calling it as a left join and not a right join.
Pratik, why are we calling it left outer join?
Yeah, because I mean that's how people have been calling it. Outer meaning any outer join essentially means all the rows of one of the tables, including the matching rows from the outer table. I get a point, Sanjeev. We are saying that we want all the rows of the left table, including the matching rows from the other table. Right? So that's the definition of outer join. Now, whether it is right or left, That depends upon what you are considering. Here, what do you think the right outer join will give us?
All the name from department IDs
And then
and null value on the employee name.
That means right outer join will actually give you, let's say, all department names. There are 4 departments, or maybe there are more, and all the employees who are assigned to the department. But there may be some department for which there are no employees. So that will remain blank. That means this is going to give you all the data from the right table, including the matching data from the left table. And hence it is called as a right outer join. Clear, guys?
Yes. And what if there is a department where there are multiple employees? It will multiply them, right?
What if there is a department which has multiple employees, right?
Yeah.
Yeah. So look at this. For
Joining with,
example, IT has 2 employees, right, Faisal?
yes, yes.
This is an output. So, okay, I mean, look at this. This department, there are 2 employees to department number 1, right, Faisal?
Yes, yes.
Now, if I did a right join, this will be the output. This one.
Oh, yeah. So it's multiplying.
This one is the output for right join.
Mhm.
In right join, what has happened is it shows all the data from the right table. So all the departments are coming 1, 2, 3, 4. But since there are 2 employees assigned to this department IT, hence the department is going to repeat in the output. But if you notice operations, nobody is assigned to this operations department 4, right?
Mhm.
So this is
It
blank.
will be blank here.
Clear?
Pratik, you were explaining this for the joins for two tables, right? If there's more than 2 tables, then will this suffice?
Sorry, can you repeat that question again, Sanjay?
I can I have seen the examples for 2 tables, right? Employee and department tables, and also examples you have shown that for the 2 tables. But if it's more than 2 tables, then also this joins will work.
Yeah, it will work for whatever number of tables. What happens is, let's say there are 4 tables you're joining together: A, B, C, and D. Right, Sanjay?
Yeah.
First, A and B will join. Whatever is the output, that would be joined with the 3rd table C. Then whatever is the output will be joined with the 4th table.
Okay. Okay. It's tough to understand. One
I mean,
and 2 will join first.
let's say these are the 2 tables.
Yes.
So they will join first. Output is this.
Yeah.
Let's say there is 3rd table. Let's say this table.
Mm-hmm.
Now this table will join with the 3rd table using the same operation like how we had discussed about Cartesian join.
Okay.
That means these 2 columns will then get added here, and each one of these rows will get combined with each one of the rows here.
Okay.
Got it? So
Mm-hmm.
A and B are joined. Now C is also joined, and then whatever is the output of A, B, C, then you will join the 4th table as well. Does make sense, Sanjay?
Yes, Pratik.
So if you remember, we had I mean, I'm going to go to my local server. In my local server, I have a file, I have a database. which has 4 tables in it, Sanjay. Okay, and the way these 4 tables are connected is publisher table is connected to the books table, author table is connected to the and books and author table are connected. Do you understand? So there is no connection between publisher and author, Sanjay. Okay.
Okay.
If say you want to know which publisher, let's say a particular author called as Ramesh is associated with, that means first you have to know the books written by that author. Then you need to know the ISBN number, the books number, and then in this table there'll be a publisher ID, the common column or the foreign key for this relationship. Through that you'll go to the publisher table and get the details from the publisher table. So the query would look something like this. From publisher P, books B, books author BA,
Author books B. Author.
AB, comma, author A, right? Where P dot pub ID is equals to B for books, dot pub ID, and B dot ISBN, the primary key of the books table, international standard book number, is equals to AB dot ISBN, and AB dot ISBN, sorry, AB dot AID is equals to A dot AID, author ID, and A dot A name is equals to Ramesh. Then P dot pub name, comma, A dot A name. Do you understand what is going on in here?
Yes.
Little bit.
We have connected the tables.
Yeah, we have connected more than 2 tables together. Right?
And by doing that, and we are finding the our output, unique one.
Yes.
So more number of table means more number of where clause.
Yes, or more number of on clauses. Tell me what should I write here now, if you really understood. Publisher P inner join books B on P dot pub ID is equal to P dot pub ID. Inner join author books AB on AB dot ISBN is equal to B dot ISBN. And what should I write here?
AB dot AID.
Author A on AB dot AID is equal to A dot AID. And sorry, where A dot A name is equals to Ramesh. Is it making sense, everybody?
It is, but we have to practice a lot to.
I mean, again, Faisal, you know, again, what I'm trying to tell you, Faisal, is it's not about memorizing this.
No, having a practice of it, having a hang of it.
It's about having the hang of it. That means conceptually you have to understand that, yes, what is the meaning of inner join? Conceptually, you have to understand that, yes, you can inner join more than 2 tables as well. Conceptually, you have to understand what is the application of left join, what is the application of right join, when do we use left join versus inner join, or when do we use left join versus right join? Do you understand, Faisal, what I'm trying to say? And it's very
Yes.
simple. If you want only common rows between the two tables, then you will use what?
Only from inner join, common.
Join, not the right or left.
Inner join.
Inner join, right?
Yes. Mhm.
When you want all the rows of the left table, including the matching rows from the right table, but all the rows of the left table matching with, including the matching rows from the right table, then left join.
joint.
And if you want all the rows of the right table, including the matching rows from the left table, then you use right join.
Right joint.
And then we also have something full join, which is nothing but left join union with right join.
Doesn't that union all thing?
No.
Wherein we have all the combination or
No,
the
no.
first part of the join?
No.
No, because we need information as well.
Yeah, we need information from multiple tables, and union will only give you data. Yeah. So let's say which was the database we were using. Yeah. So let's say I use this one. There are 4 tables in it. There are bridge table, chess table, music table, and student table. So between the student music table and the student table, there is a common column called as student ID or ID. So if I say I want all the rows from the student table, I want all the rows from the student table, including those students who are playing musical instruments and the type of musical instrument they're playing, plus the students who are not playing musical instruments, right? So what would I write? So from students S left join music M on S.id equal to M.id. S.id, comma full name, comma type. Now this type is a column from the music table. Full name is a column from the student table, and ID is a common column between them. So if I run this statement, it gives me the list of all those. And if you notice, it's showing null for some of these students. Do you understand why it's showing null for these students?
Because
they are not in music team.
Because their IDs are not there in the music table. Is this clear?
Yes.
And now just look at how versatile this, SQL can be. If you just simply change this left join to right join, then it shows you all the data from the music table. Now it seems like all the musical instruments are played by somebody or the other, but it's not showing you those extra rows which we saw earlier, which came from the student table.
Because that is not the part of the music table. That's
absolutely right.
And you are talking about the all joint, right joint, left joint. There is also one.
Then there is full join. So just take these 2 queries and do a union between them. I get a point. So this is, if you do a union between them, it is like this. Is it making sense, everybody?
Pratik, here, the intersection part will be counted as once.
Once, because of this union.
Okay.
Right? So did you understand how easy it is to do with left join, right join, inner join, and also full join?
Pratik, I didn't get this union part.
See, what are we, I mean, did you understand what we're trying to do here? We wanted full join will give you what? The list of all the students of playing musical instruments and the type of musical instrument they're playing, along with the list of all the musical instruments which students are playing and the instruments which nobody else is playing, which essentially means all the rows from both the tables. I get a point, Tarun.
So we'll get the list of all the students who are playing.
All the students who are playing musical instruments, not playing musical instruments, plus all the musical instruments which nobody is playing.
Yeah.
And the list of musical instruments which students are playing, you know, the type of musical instruments.
Pratik, so it's basically the rough filtered in which we just be adding the unfiltered data of all, both the tables which we are intersecting.
Yeah. So it's like zone number 1, students who are not playing musical instruments. Zone number 2, the list of students who are playing musical instruments and the type of musical instrument they're playing. List number 3, which is the list of musical instruments which nobody is playing. I get a point.
So union is just a upper point, and in the inner join and the left or right join, we are just filtering the inner data.
Nay, left join gives you, again, from a Venn diagram perspective, left join will give you this portion. All the rows from the left table, including the matching rows from the right table, Shikhar.
Okay. Yes.
And right join will give you this portion. All the rows from the right table, including the matching data from the left table.
But in union, we see the whole part from both the tables and the in the
whole part. But this common column, these common rows will be counted only once.
In union.
In union. In full outer join.
Okay, Pratik.
Pratik, I understand all of it except the 4 where you're joining the 4 tables. So I'll just go back to your query. Then I will come back if in case I don't understand.
Sure. I mean, especially if you look at this one, this method, this is same as the previous method, you know, table 1, comma table 2, where table 1 dot common column is equal to table 2 dot common column, right? Now here we have added 2 more tables. So we said and table 2 dot common column is equal to table 3 dot common column, and table 3 dot common column is equal to table 4 dot common column. And we have added one more condition.
Okay, yeah.
Okay, guys, I have taken extra time, but very important class, guys. You know why I'm saying important classes? It's more about conceptual understanding, because if you understand this, then you understand something called as data modeling. And if you understand data modeling, then when you go to Power BI or, you know, a Tableau kind of visualization tool, which we call it as a business intelligence tool, right? There we normally work with data residing in multiple tables. So then it becomes very easy for you to understand what is really, how are we creating those reports, right? I think in your course, we also have Power BI, right? If I remember it correctly.
Yes, and Tableau as well.
Yes.
Yeah. So when you actually go to Power BI and Tableau classes, then you'll again understand the importance of joins, because there also you would be fetching the data from multiple tables and creating visualization storyboards and dashboards, right? And again, the fetching happens through common columns.
Okay. So Pratik, are we learning the concept here? And will we use?
We will also use it here also, Sanjay.
No, I understand that. But I wanted to know that, this SQL will be used there also in
Yes, there
Power
also.
BI.
Yeah, in Power BI also you will use SQL there as well. You'll use all these concepts there as well. Like table, relationships, joins, all these union, all those concepts you will use there as well.
So there's no piece in SQL for visualization. So we
Yeah,
cannot.
SQL is a language, Faisal, है ना? So what happens is all the visualization tools and the reporting tools like statistical tools like Python and whatever, any reporting tool, right? Whether it is statistical or visualization tool, they need access to the data, and the data resides in tables in the databases. And that's where SQL comes into the picture. So SQL will do a lot of backend operation for them.
So basically, we are using SQL to interact with the database or
Databases.
pull out the database, and visualization happens in some other software.
Some other software. You
Okay,
can
but
take
I
this
understood that. With these queries, we'll take out the data results, and then we will do the reporting part on other languages, right?
Absolutely. In my class here, in this class also, because you now guys have had Excel class already with with Ishani, I will show you from within Excel also. Just remind me if I forget, before I forget that, that I'm also going to show you that from within Excel also, how can you run a SQL query?
Yeah, Power Query, something like that.
Yeah, Power Query. Okay. That is also very interesting. So there also you will actually write a SQL query, get the data from a database directly, and then do the visualization in Excel.
Okay.
This SQL thing, the coding typing will happen in Excel while doing the Power Query, or?
Yeah, can happen and can also not happen. But if you know it, it becomes significantly easier. And you will then be able to control your data, like a magical wand.
That's interesting.
Okay.
So I will show you. I'll probably take a 15 minutes session on that also. That'll be interesting to understand. Okay, guys. Just before people start dropping, I know a few people have already dropped. I am going to upload the scripts for inner join, left join, right join. If I have not already done that, I think I might have already done that, but I'll just quickly check whether I have uploaded those scripts also or not. I might have already done it, but I will check it again. Then, okay, maybe I have not, so I will do it. I will do it today. Oh, scripts for joins is there. Just need to check.
So Pratik, can you also send that thing, the Excel you work on, right? For explaining.
Actually, it is uploaded, Sanjit. I will upload it in today's session as well. It was uploaded in the beginning only, but I will upload it again.
No, it's not uploaded, Pratik.
Because I haven't seen this.
No, it's not, because even I wanted to ask you this.
Okay, no problem. If it is not uploaded, I will upload. My mistake. I will upload it.
Thank you
In
so
this
much.
Excel, what happens is, of course, we are not in classrooms anymore. So, what I like to do is that I like to scribble all the things here, give all the examples here. Yeah, so I will do it.
And that is fed in our heads, so we
Yeah,
can
no
go
problem.
back on it and revise.
Yeah, no problem. I will do it. I will do it. Okay, so I'm going to give you guys a few questions on on inner join, outer join more, but from a different database. Okay, maybe I will this time do it on maybe I'll do it on credit card, or I'll do it on school database. I'll just quickly check. Okay, but do try to work on those questions. I'll not give you a lot. I'll just give you like 4 or 5 questions. That's about it.
Okay.
Thank you, everybody. Have a good day.
Thank you, Pratik.
Thank you, Pratik.
Very nice session. Thanks.
Thanks a lot.
Thank you, everyone. Thank you.